In this video, we're going to take a look at a type of loop called a for loop. Now, looping is basically what computers were built to do. Here's ENIAC. It's one of the first computers ever built, and its job was to just repeatedly calculate artillery shell trajectories. Basically a loop. So let's just get some definitions out of the way. A loop is a set of instructions that just repeats until some condition is true. And for loops, which we're going to study in this video, are generally used when you know how many times you want to repeat the loop. This is in contrast to a while loop, which we're going to study in a different video. So let's just get a for loop up on the screen here, and we'll analyze its various pieces. Here's a for loop that just prints out the word hello 100 times. Well, let's look at it a little more systematically than that. The first part of this stuff between the parentheses is called the loop initialization. This is where we declare a variable that's going to act as our loop counter. It's going to keep track of how many times we've been through the loop. The next part is called the test condition. As long as this test condition is true, the body of the loop will keep executing. I'll specify what the body is in a second, but basically it's the stuff between the squiggly braces. After the body of the loop has been run, we increment or decrement the loop counter. Usually we add 1 to it or we subtract 1 from it. We could multiply it by 5, divide it by 2. Typically add 1 to it. But it's going to depend on the specific case that you have. Now the stuff between the squiggly braces is called the body of the loop. And again, here's how it all works. When the loop starts, we do the initialization. Then we run the test condition, and if the test condition is true, we do the body of the loop. Afterwards, we do the increment or decrement piece, and then go back to check the test condition. And as long as the test condition is true, this thing will keep running along until the test condition isn't true. And when the test condition isn't true, we jump down to the end of the squiggly braces at the end of the loop, right? The loop is done. We're not going to loop anymore. So that's how it works. Here's what it looks like as a flow chart. We do the initialization first, then we check the test condition. If the test condition is true, we do the body of the loop. Then we do the part where we increment or decrement the loop counter, and then we go back and we check the test condition. And we just keep going around in that little circle over and over again until the test condition is false. When the test condition is false, we bail out of the loop, and we're done. Now let's take a look at a way we might use for loops. For loops are great for initializing arrays of things. Here I have an array of 50 monsters, so I know exactly how many times I need to loop. I need to loop 50 times. So there's a for loop that loops 50 times, and for every cell in that array, it's going to make it point to a new monster. All right, so there we go. Now what if I were trying to initialize a two-dimensional array, like a grid or a board or something? Well, then I would use something called a nested loop, and that is a loop within a loop, right? And these are great for initializing two-dimensional arrays, right? If you wanted to initialize a three-dimensional array, right, you could have 3 nested loops, right? So let's take a look at that. Here's our example, Connect 4, which we're going to do in this class. Now that board right there is a two-dimensional array, right? It is a grid. So what I need is a loop that goes over each row or each column, and then for every column, for every column, it's going to go down through the rows, right? For this column, it's going to go down through the rows. For this column, it's going to go down through the rows. So it's a loop within a loop. Right? Let's take a look at that. So here's the example. This is the reset function from Connect 4. So for every column, so now I'm going to go over the board going across, and now I need a loop inside here that's going to go down. So now there's another for loop. There's a for loop inside a for loop, and what this is going to do is it's going to cover every combination of row and column, right? So inside the nested loop, or inside the inner loop here, I've got a statement that sets the board cell at that row and column to be empty, right? And then at the end I call draw board. Now draw board is also going to be a nested loop. It's going to do the same thing. It's going to go over all the rows, all the columns, and it's going to call the draw function on every cell on the board, right? So there we go, nested loops. Now let's look at another variation on the for loop called the for each loop. For each loops are simplified for loops, and they are great for iterating over things called collections. A collection is exactly what it sounds like. It's just a collection of stuff. So arrays are collections, lists are collections, maps are collections, sets are collections. Those are all data structures that contain other data structures. And for each loops are very convenient for iterating over those things. So let's take an example here. I have a string array, or an array of strings called colors, and its elements are red, green, and blue. So let's write a for each loop to iterate over this array and print everything out. So I start like this. I have a for each and then parentheses and squiggly braces. Notice this is starting to look a little bit like a for loop, but you'll see the difference in a second here. And then I have to give a data type and a name. So for every string, which I locally refer to as S, do something. Now we're missing something here though. We need to say what collection we want to loop over, and here's how we do that. So we say for every string, which we're temporarily referring to as S, in the collection called colors, just write it to the console, right? So this is going to loop over every element in colors. We're going to refer to it as S, and then we're just going to write it out. So that's a for each loop that would loop over that collection and just print everything out to the console. And notice this is a lot simpler than like for I equals 0, I is less than 3, I plus plus, right? That's just a little more elegant and readable. Okay, lastly, I want to talk about the break statement. At any time, if you realize that you need to stop looping, you can use the break statement to jump out of a loop. So let's say you have a list of 50 things and you want to loop over it until you find one particular one that you're looking for. Once you've found it, you can use the break command to jump out of the loop, and you don't have to needlessly search the rest of the list or array or whatever it is that you're searching. So a break statement will just jump you out of a loop down to the end. So that's it. We've talked about for loops, nested loops, for each loops. If you have any questions about loops, please let me know. This is very important stuff because we are going to be using loops so much that you will feel that you are stuck in a loop. So again, if you have any questions, please ask.